Hi everyone, we're going to continue talking about section 3.3 and we're going to pick up with talking about where a function is increasing, decreasing, and constant. So, a function f is an increasing function on an open interval if f of b is greater than f of a for any two input values a and b in the given interval where b is greater than a. So basically what that means is, think about this. If we are reading a book, we read from left to right. So when we look at a graph, we are looking at it from left to right. When you learn slope for, let's say, linear equations, if it was going up from left to right, we considered that positive. So start on the left-hand side of the graph. Okay, so on the left-hand side of the graph, I'm going to start here, and look, I'm going up. So I'm going up until I get to that point. So this is where it is increasing. Now, in this case, let's say here's A, here's B, or the X in that case, FA and FB. And FB is going to be greater than F of A because it's higher. So it does fulfill that definition. Let's see, where else is the graph going up? The graph is also going up from here to there. So it's going up from left to right in those two places. And then it's decreasing where f of b is less than f of a for any two input values a and b in the given interval where b is greater than a. And again, you read this and it's kind of like, what in the world does this mean? But basically what it means is, if I'm looking at the graph and I'm reading it from left to right, where is the graph going down? So it is going down where I highlighted it in orange. So what you do, however, so it's decreasing. Sorry, I didn't write. It was increasing here. And then I did not write that it was decreasing. So let me write that as well. So you can kind of see where it's increasing and decreasing. So it's increasing in two places. It's decreasing in one place. And so when they ask where is it increasing, where is it decreasing, it means for what x's. For what part of the domain is it increasing? For what part of the domain is it decreasing? So look at only the x values. So if you think about the domain of this function here, the domain is from negative infinity to positive infinity. So in this case, it is increasing from, negative infinity all the way to this point here, which looks like it's between the x values between -2 and -3, so it looks like -2.5. Now, since it changes direction at 2.5, we can't say that it equals 2.5 there. I mean, it does, but what I mean is it stops increasing at 2.5 and it changes direction. So two things are kind of happening at -2.5. So we're going to use parentheses there. So it is decreasing from -2.5 all the way to here. And the x in this case is 1. And then it's increasing again from 1 to infinity. So we're just going to write the interval of the domain, the portion of the domain where it's increasing, the portion of the domain where it's decreasing. And if it is a flat line, a flat horizontal line, that is where it's going to be constant. Okay. So let's move on. All right, so we're going to find increasing and decreasing intervals again, given the function, where is it increasing and decreasing. So I like to just kind of highlight portions. It's going up, and now it's going down, so decreasing, and then it's going up again. So increasing, decreasing, increasing. So we have to figure out, okay, what are the x values at those places? So I kind of draw a vertical line where it changes direction, and that helps me to see what the x values are. So it's increasing from, oh, look at this. This isn't an arrow. This is a point. So it looks like it's really close to -8. So I'm just going to say that it's increasing from -8 to, it looks like it's between -2 and -4, so that'd be -3. And it's also increasing from 3 to, oh, this looks like 7. Again, we're looking at the x's, not the y's. And then it's decreasing from -3 to +3. And we always just put the intervals where it's increasing and decreasing. We always just use parentheses for those. We just use parentheses. Okay, moving on. So you guys try it. Find where it increases and it decreases. So pause, and when you come back, we'll talk about where those intervals are. Okay, so it looks like we start by decreasing. We're decreasing, and then we change direction, and now we're increasing. Oops. Forgot the highlighter. Now we're increasing, and it looks like they changed directions right here. Okay, so it looks like we are increasing from x equals 1 to infinity. And then it looks like we're decreasing, because we're increasing here. It looks like we're decreasing from -infinity to 1. All right, so now let's talk about local minima and local maxima. So a function f has a local maximum x equals b. Oh, I'm sorry, at x equals b, rather. That makes a difference here. Let me start over. A function f has a local maximum at x equals b if there exists an interval a to c with a is less than b is less than c, such that for any x in the interval ac, f of x is less than f of b. So basically what it means is that here's a, here's c, here's b, and here's the graph. So here's the function at b, here's the function at a, here's the function at c. So over that function from a to c, f of b, which is right here, is going to be higher than f of a. And if that's the case, and it's also going to be higher than f of c. So if this is the case, okay, so likewise, f has a local minimum at x equals b if there exists an interval ac where a is less than b is less than c, such that for any x in the interval ac, f of x is greater than f of b. So this would be kind of where here's your a, b, c. F of a is greater than f of b. So it's a lower point, kind of in the midst of the whole thing. So estimate the local extrema, or the local extreme of the function. So the local, what we want to find out is there a local maximum? And is there a local minimum? So basically what you look for peaks and valleys. So if you look, here's a valley. So there's a lowest point here. So that is a local minimum. And what you give for your answer here is the y value. So this is y is -1. So it has a local minimum at -1. And then, so if you have a valley, that would be a local minimum. If you have a peak, like this one, right here, then the top of that, the highest point, that's your local maximum. Again, give the y value. In this case would be 1. So the local maximum would be 1 and the local minimum would be -1. So look for peaks and valleys. Now, that's slightly different from absolute maximum and absolute minimum. So absolute maximum is basically what it sounds like, the absolute max on the graph, the absolute minimum of the graph. So in this case, what is the absolute maximum? Does it have one? And then what is the absolute minimum? So if you look at the definition, it says that for the function f at x equals c, if f of c is greater than or equal to f of x for all the x's in the domain. So over the whole domain, is there an f of c that is greater than all the other x's? Then that would be the absolute max. And then the same thing for the minimum, absolute minimum, if there's a point, we'll call it d, where f of d is less than all the other f of x's in the domain. All the x's that you would plug in for the function, all the x's in the domain. If there's a point that's lower than all the points for all the other points in the domain, then yes, that is an absolute minimum. So in this case, is there a maximum and is there a minimum? So it looks to me like we do have both here. The absolute lowest place is here. This would be our absolute minimum, because there's no other point on the graph that is lower than this. Now, I just want to contrast with this up here. We had a local minimum right here, but this was not the lowest point on the graph, because this graph keeps going on to negative infinity. It keeps going down. So that's why we call this a local minimum. It's not the absolute minimum, but it is a minimum on a certain interval. But for absolute minimum, we're looking at the whole graph. So if you look at this whole graph from left to right, the absolute minimum is the lowest point. And again, we give the y values. In this case, the y is -2. All right, and oops, I wrote that in the wrong spot. And it makes me want to go back and look and make sure I wrote my maximum and minimum in the right spots there for the locals. And I did. Okay, yay. All right, absolute maximum is the absolute highest point on the graph. So in this case, the absolute highest point is here. And again, we give the y, which would be +2. All right, so you guys try the next one, absolute max and absolute minimum. Pause the video, and when you're finished, you can come back and you can go over the answer with me. All right, so where's the absolute lowest point? That's right here. That's your absolute minimum. And it looks like the y is -2. Your absolute maximum is here and there. So that looks like the y is 4. So absolute max happens in 2 places, but that's okay. They both have the same y coordinate. And that's all that counts. All right, so you can look back through in the textbook, or you can go through this PowerPoint the set of notes and then look at the toolkit functions, the constant, identity, quadratic, cubic, reciprocal, reciprocal squared, cube root, and square root and absolute value, and look at the intervals for which it's increasing and it's decreasing. And that will help us as we look at graphs of functions that have these functions as a parent function, meaning it's the same basic shape but it's moved around a little, and that will help you with where it's increasing and decreasing and that kind of thing. So look over those, and that's all I have for this section. So if you have questions, please let me know.